Hi everyone, welcome back. Let's see longest remaining time first algorithm. In short, we can call it as LRTF algorithm or LJF with preemption algorithm. Guys, in the last videos, we have seen LJF, which is of two types. One is non-preemptive, another one will be preemptive algorithm. In non-preemptive algorithm, if I get a chance to execute, I will completely execute it. In preemptive, even if I get a chance, if I got any kind of higher precedence job, I have to compulsory give chance to it. Right? So general logic behind longest job first algorithm is how we are going to get the priority if I get any job which is having highest burst time among all the process, then that particular process will give the highest priority, right? So that we'll see with respect to preemptive mode, and the criteria will be burst. So if you are not able to understand the definition even by simply looking into this particular example, you can understand it. I am trying to write Gantt chart for you. CPU with 0 nanoseconds. By the time of 0 nanoseconds, any process is available? No. So CPU is idle for 1 second or 1 unit of time. By the time of 1 unit of time, process 1 is available? Yes. So given chance to process 1, because there is no competition, I will allocate 1 unit of time, then it will done it by 2 units. As it is done 1 unit, so its leftover is 1 unit of time. Now the time is 2 units. By the time of 2 units, what are the processors available for us? Process 1 and process 2. Right? When process 1 and process 2 are available, which one will get the chance? That depends upon the algorithm what we are using. LRTF algorithm we are using, right? Means it is going to give the chance to the process which have the highest burst time, right? So out of 1 and 4, it is going to highest burst time. So give chance to P2 and allocate it for 1 unit of time, that will be 3. As allocate 1 unit of time, it will left over with 3 units of CPU requirement. By the time of 3 units, what are the processors available? Process 1, process 2 and process 3. Right? So when these 3 are available, which one will get the chance first? Process 3 will get the chance because it's having the highest burst time. 1 unit of time is allocated. Now, by the completion, as it is allocated 1 unit of time, I have to reduce it by 1. By the time of completion of 4 units, what are the processors available for us? Process 1, 2, 3, 4 are available. Right? When these are available, which one will get the highest chance? The process which is having the highest burst time. So, which is having the highest burst time. So, I will allocate it to P4, 1 unit of time, that will be 5. Now, by the time of 5, all are available. So, you have to give chance to which one? The process which is having the highest precedence, right? So, now I will allocate one more time, P4, 1 unit of time, that will be 6. It will decrement by one more time, that is 6. Now, again, P4 is only the highest burst time. P4 allocated 1 unit of time, 7 will be done. Right? Now, by the 7 units, 2 processes having the same precedence. One is P3, another one is P4. Then which one will give the priority? According to the arrival times. The process which is having the less arrival time, first arrival time, that we can go with that. Right? Now I will give chance to P3. If I give chance to P3 for 1 unit of time, that will decrease by 1. By time of arrival of 8 units, again P4 having the highest burst time, so it will reduce by 1 more unit of time. That means P4 will be allocated 1 and 9. Now both are having again same burst time. Now we'll give chance to what? P3, 1 unit of time, that will be 10, it will be decremented by 1. Now the next precedence will be given to P4 because it's having highest burst time. 11. Now if you observe, by the time of 11 units, there will be 3 processes whose bus times are same. Now which one will you give the chance? I will give the chance to P2. Because it's having the less arrival time. P2 done by 12. Now I will give chance to P3, 13. Right? It is a kind of large problem. Next, I will give chance to P4 because out of all, highest bus time will be given to P4. Now again, all 3 having the same precedence, so I will write directly just P2, P3 and P4. This will be 15, 16 and 17. All will be decremented by 1. Now, all having the same precedence. When all having the same precedence, you have to go with the order of arrival time. So, I will give chance to like this. P1, P2, P3 and P4. So, 1 unit of time. So, it will be 17, 18, 19, 20 and 21. Now, all the process completely starts. Right? This way, LRTF is going to work for you. Right? Yes. Fine. So, what is the scheduling length here? Scheduling length will be 21 minus 1, which is equal to 20. Right? So, what is the general meaning of scheduling length? All those things you can observe in the earlier videos. Right? Have you observed here any starvation? Yes. Starvation will be definitely exist because if there is any process which always gets with highest bus time, definitely the lower bus time process will lead to starvation. Okay, hope you understood this video clearly.